Hello and welcome to today's video where I'm going to be showing you how to complete a radar plot. So for radar plotting, the first thing we need is the plotting sheet, which consists of the radar screen and a scale along the side. We're going to determine a couple of things in advance. We're going to be doing a 12-minute plot, and our own vessel is going to be doing 10 knots going 000, so due north. This means our own vector is going to be 2 miles long as measured on our scale, because in 12 minutes at 10 knots we would have travelled 2 miles. And then we're going to place it in the centre of the screen, pointing due north. This just represents our own true vector. The screen itself, we're going to take, it's roughly 6 miles. It's give or take a little bit just because of the dimensions of the screen though. But yeah, we're going to call this a 6-mile plot as well. So, as soon as we receive our first echo, we can't really determine much. All we know is the range and bearing of the target vessel. We need to continue to monitor to find more information. Then we find the next point. Again, we haven't quite got enough here. We're really working on scanty information at the moment. There's not enough to complete the plot. And then finally, 12 minutes after the initial plot, we get our third plot. So each of these plots is 6 minutes apart. The full range is 12 minutes, as we've previously said. So all we're going to do to immediately find the CPA is we can join a line straight through the middle. And in this particular example, the closest point of approach is 0. If we do nothing, there will be a collision. Now, to find out how long until that collision, we need to measure a couple of distances. This first distance here, we need to find out how far the target vessel has travelled in the 12 minutes we've been plotting it. All we do, transpose that onto the scale, and we see in the last 12 minutes, the target vessel has moved 1.5 miles relative to us. Then, we need to find the distance that the target vessel has got to go from its final position until it reaches us. Again, we're going to transpose this onto the side scale and measure up to find it's about 3.3 miles. To work out how long it's going to take to travel that, we need to do a ratio between these. The ratio of 3.3 to 1.5 will be the same as the time to go to 12. And we simply lay it out like this. All we do is move the 12 to the other side, simple algebra here, to find the time to the closest point of approach, and running that through the calculator, rounding off to the nearest minute, we get 26 minutes. We can start writing these down the side. So our CPA, as we've